Welcome back to another video for Foundations of College Algebra. Today we're going to be talking about inequalities and how to work with inequalities, the linear ones, and how to express our answers in interval notation. So first thing, let's talk about how it is we even write an inequality. So we begin by, we're used to equalities. So let's say x plus 6 is equal to 8. That's an equality coming from the equal sign. Now an inequality, let me maybe write this here. An inequality is going to be something that expresses not exactly equal, but going to be less than or greater than some value. So let's start out with greater than. So whenever you see this symbol, that is you read that as greater than. And so for example, we have 8 is greater than 6, 20 is greater than 10, you get the idea, it's greater than. And then we have a corresponding sign, this one, maybe put some bars here. This is, you read it as less than, and that works just like you would think. So using the two examples from above, 6 is less than 8, and 10 is less than 20. And you can see that the way these signs are kind of created is to suggest that if you read it backwards, like you see here, that if you read it forwards, 8 is greater than 6, but if you read it backwards, you can see that less than from the other perspective, 6 is less than 8. So if 8 is greater than 6, then that's the same thing as saying 6 is less than 8. And finally, we have ways to make this also possibly include equality. So it's not strictly less than. So for example, 6 is strictly less than 8. But if we want to say we want something here that allows us to have, maybe 6 is less than 8, or maybe, we want to say 8 is something compared to 8, we use less than or equal to. And this less than or equal to sign is very standard. That's how you typically use it. But if you look in like older textbooks, or sometimes you'll see it as less than or equal to, they'll have the explicit equal sign in there. But for what we're doing here, we're going to keep just the just the sign we have there. We have 8 is less than or equal to 8. 6 is less than or equal to 8, right? So less than or equal to includes less than, and it includes equal to. Same thing with greater than or equal to. We have 8 is greater than 6, but if we want to include something where maybe 6 is greater than 6, we could have 6 is greater than or equal to 6. Again, 8 is also greater than or equal to 6 because it's greater than. So here we have, you read this as less than or equal to. And here you would read this as greater than or equal to. We can actually chain these together. So let me give you an example. The number 10. That is going to be less than 20, but it's also greater than 5. So you can see that we have kind of this triple thing here, where you would read this if there are a few different ways to read it. The very technical way is 5 is less than 10 is less than 20. Right, and that should make sense, because 5 is less than 10, and 5 is less than 20, and 10 is less than 20. So 5 is less than 10, which is less than 20. Another way to read this is looking at this middle element, is 10 is between 5 and 20. right? Does not include 5 and 20, but between 5 and 20. So you can probably see where we're going to go with this. We have, we can start doing equations with, not equations, we can't call them equations because equations has that equa part, meaning an equal sign. But we can do inequalities with these. And so let's go ahead and try. For example, if we want to say x is between 5 and 20, there we are. If we want to say x is greater than 10, we can write that just like we're saying it. If we want to say that the sum of 6 and x is greater than 4, we got that. If we have the absolute value of x minus 9 is less than or equal to the absolute value of x plus 10, then we can write that. So you can see that we can start doing what we've learned before with the linear equations to these inequalities. So let's talk about interval notation. So if we want to say that a is less than, first, let's actually talk about the number line. Let's say x is greater than a. And instead of being generic here, I'll say 5. Then we can draw a number line. Here's maybe 0, 1, 2, 3. I shouldn't have started at 0. Start at 2. Oops. Start at 2, 3, 4, 5, 6, 7, and it keeps going that way. And we want to plot where x is greater than 5. Well, we know x is greater than 5. Let's say at 6 and above, we know that's the case, right? 6 is greater than 5, 6.5 is greater than 5, 7 is greater than 5. And then all the way down to 5, we know all of that is greater than 5. But we can't include 5 because 5 is not greater than, strictly greater than 5. And so the way we say that, where we can get infinitely close to 5, we could do 5.1 is greater than 5, 5.01 is greater than 5. I mean, we could get infinitely close to 5 from the right, but we can't actually use 5. The way we write that is with a circle. So x is greater than 5, the way we write that on the number line is like this, where that red is. And the way we write this in interval notation is 5 infinity. And on the left-hand side, we're going to use parentheses. On the right-hand side, we're going to use parentheses. And what these parentheses mean is you can get infinitely close to it, but you can't actually reach it. Now, anytime you see an infinity, you have to use the parentheses because you can never reach infinity. Infinity isn't a number. But you can get as close to infinity as you want, right? You can keep going and going and going and going. Same thing here with 5. You can get as close to 5 as you want, but you can never reach 5. So now let's look at an example. So this is interval notation. Let's do x is greater than or equal to 5 this time. 2, 3, 4, 5, 6, 7. So it's going to be the same way. Everything above 5 is going to be included, but this time we can include 5. So we're going to write that with a solid point. And the way we write this in interval notation is, again, we can go from 5 to infinity. We can never reach infinity, but we can keep going. But we include 5 this time. And the way we show that we can include 5 is with a bracket. So that says we can go all the way down to 5, including 5. Whereas up here, we're saying we can go all the way down to 5, but not including 5. Now, one note I want to make, if you read especially newer style textbooks, authors sometimes for this notation, they like to use like backwards brackets. Just, I don't know why you would need to know that, but in case you ever see backwards brackets like that, these are the same thing. But for what we're doing here, and for all intents and purposes, we're just going to use parentheses. Okay. So whenever it's strictly greater than, you're going to use a circle. Same thing if it's strictly less than. Whenever it's strictly, or whenever it's greater than or equal to, then you're going to fill in your circle. Let's look at, so far we've seen something of the form AB. We've seen something of the form AB. And again, what that looks like is on the number line, it looks like, here's A, here's B. And B may be infinity, so this actually may just keep going off forever, like what we saw in the previous example. AB, we've seen, looks like, here's AB, solid dot here. Maybe I should do this in red, kind of like I did before. Solid dot here. It's going to go, it can get up to B, but not include B, so it's an open circle. And then we have kind of the opposite of that. A, here's B. We have open circle on A, full circle at B. And then we have, sorry, we've already done that one. A, B, which is, here's A, here's B. Whoops, full circles on both. And the first one's going to correspond, and I should have left room for this. The first one's going to correspond to x is between A and B. The next one's going to be is A is less than or equal to x is less than B. This one is A is less than x is less than or equal to B. And this one is A is less than or equal to x is less than or equal to B. Now we can, so this is how we talk about the interval for which our inequality is valid. So for example, the interval for which x is greater than 5 is valid is 5 to infinity. The interval for which x is greater than or equal to 5 is valid is from including 5 to infinity. And so these are how we notate where our inequality is valid. We can actually stitch together inequalities, the solutions to inequalities. So maybe we want that, let's say 1 is less than x is less than or equal to 2, and 5 is less than or equal to x is less than 6. I don't know. So and we're going to stitch these together with an or. So either x is between 1 and 2, including 2, or x is between 5 and 6, including 5. So the way we would write that on a number line, let's see if I can get all of them on here. We got 1, 2, 3, 4, 5, 6. Okay, so x could be between 1 or 2, 1 and 2, including 2. So solid on 2, open on 1, interval in between. And then x could be 5 to 6, including 5, not including 6. So this is what, x could be in one of these categories. And the way that we write that in interval notation, well, we have the 1, 2, we know how to write that. And we know how to write 5, 6. And the way we put them together is with a set operation called a union. And the union looks like a big U. And that says, whenever you read that, you can read basically an or. you know, it's the solution is 1 to 2, or the solution is 5 to 6. It could be either one. It could also be both. In this case, it can't be both, but if there's any kind of crossover, it could be both. Okay, let's talk about one more thing in our crash course here with equality or inequalities, and that is going to be multiplication and reciprocation. So let's say negative x, whoops, don't know how that happened, negative x is greater than 7. Then whenever we multiply by a negative, we have to flip the sign. So this means that x is less than negative 7. Same thing if we did negative x is greater than or equal to 7. Whenever we multiply by a negative on both sides to get rid of the negative, so I guess maybe I should make that explicit here. We multiply both sides by negative 1, then we have to flip that. Same thing here, whenever we multiply both sides by negative 1, we have to flip the inequality. So you can see greater than becomes a less than, greater than or equal to becomes less than or equal to. Same thing with reciprocation. So if 1 over x is greater than 7, then we get that x is less than 1 over 7. If 1 over x, let's say, is less than or equal to 7, then we get that x is going to be greater than or equal to 1 over 7. Okay, now we have all the rules, finally, to be able to solve our inequalities. So let's look at maybe 2. We'll look at 2. Negative 3/4 x is greater than or equal to negative 5/8 plus 2/3 x. So we're going to go about solving this just like we would solve it as if there was an equal sign, just keeping in mind the rules we have for inequalities. So let's add 3/4 x to both sides. We get 0 on the left is greater than or equal to negative 5/8 plus 2/3 x plus 3/4 x. And then let's add 5/8 to both sides. We get 5/8 on the left is greater than or equal to 2/3 x plus 3/4 x. Now let's simplify the right-hand side. The least common multiple between 3 and 4 is 12. So in order to get 12, we have to multiply by 4 over 4. And in order to get 12 here, we have to multiply by 3 over 3. Two times 4 is 8 over 12x plus 3 times 3 is 9 over 12x. 8 plus 9 is going to give us 17 over 12. Uh, 5/8, 17 over 12x. Okay, now we can multiply both sides by the least common multiple of 8 and 12, which is going to give us 24. So multiply both sides by 24. We get, let me just write that explicitly here, 24 here, 24 here. We can, that's going to end up being 15 on the left. On the right-hand side, that's going to end up being 34x. Now we can divide both sides by 34. And we get that 15 over 34 is greater than or equal to x, which is the equivalent way of saying x is less than or equal to 15 over 34. So our solution on the number line, let's say here's 0, and let's say here's 15 over 34. It can include 15 over 34, it's a solid circle. Goes all the way out to infinity. right? Because it could go down to negative infinity, because as low as you want, and it's still less than 15 over 34. And the way we would write that on interval notation is that x is in, let's see, you actually wouldn't have to know how to write that. If we did it just in interval notation, the interval here, we would have negative infinity, it's 15 over 34. One more example. I pulled this one straight from Lumen, because I think it's good. We have x plus 20 is less than 15. Okay, there are two cases here. If, and maybe I'll see if I can divide it and maybe write small. We could have if x plus 20 is greater than or equal to 0. And we could have if x plus 20 is less than 0. If x plus 20 is greater than or equal to 0, then the absolute value of x plus 20 is going to be just x plus 20, right? Because it's positive. Taking the absolute value of a positive number doesn't change anything. So we pretty quickly get that x is less than negative 5. Now, if x plus 20 is less than 0, then we're going to have to change the sign. It's less than 15. So we need to multiply by a negative and get plus 20. Now we have to flip the sign because we multiplied by the negative. And then subtract negative 35. Notice in this case, we also have the, we have this, and we could actually write that in here as, notice that this is the same thing as x is greater than or equal to negative 20. This is the same thing as x is less than negative 20. So we could actually throw that in there and say, well, here x has to be greater than or equal to negative 20. And here x has to be less than negative 20. So our interval here, I'm not going to draw the number line. I'll, well, maybe I will. Maybe I will. Let's see. We'll put 0 here, 5, 10, 15, 20, 25, 30, 35. It's negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35. So we can be between negative 20, including negative 20, and negative 5, open circle. Or we could be between negative 20, open circle, and negative 35, open circle. Whenever we union these two together, and maybe I'll put this as green, are when we union them together, I'll do this as green, we get a circle over here and goes up here, and then we have or this. At that point, we're saying basically there's nothing on the top, but there is something on the bottom, and since we're using an or, it still counts. So we can keep going up to here, to negative 5. And so on the top, we could write this as negative 35 to negative 20 union, negative 20 to negative 5. On the bottom, we said that that is just equivalent to negative 35 to negative 5. Right, because this is kind of picking up where that leaves off. So there's the final answer in interval notation. Here's the final answer in on the number line. So essentially x can be between negative 35 and negative 5. Okay, I think that's going to do it for today's lecture. It was kind of a lengthy one, but it covers basically an entire module.